I will show you a case with an implant planning. So starting from the implant planning to the immediate loading finally. No? And we will see the different way to approach this kind of restoration, different way that we can use in the Zirkonzahn software and with the Zirkonzahn materials to have an immediate loading. So we will touch different software starting from the project, so the archive, then the scanner software, the implant planner, the modifier, which is the newest software we have. And you can also see that we can create really easy setups in the modifier software. And I will show you how during this case. And that's the topic of today. And then I will show you some video about the companies, about the clinical part, and so you can see a little bit also this part. And I will show you also some model in the reality with the live cam, some model with some different material. I will show you the skin bodies that we can use, etc. So good. Let's start with this webinar, and start from where? Start from finally the archive. No, the archive is basically the first step. So the archive is the software that allow us to create a project and to have an idea about what we would like to do. So we can start for this kind of cases. We can start from the archive, or we can have a look also inside into the implant planner. We can have a look also about the combined data we have. That's let's say the starting point. So we can start both together. But first of all, we will create a setup. So, but basically the setup or the setups, this case. Just to show you, to speak about the case. This case was an upper and lower full arch. The doctor decided to remove all the implants, the old implants, because there was some problem with the bone, etc. When there was after not so many years, there was a losing bone from the patient, so he think about replace the implant and do everything with surgery guide. It was a partial surgery guide case, not fully guide, because the doctor decided also to smooth a little bit the bone and to open it. But anyway, everything is start from a setup, so we have to create our setup just to have an idea about our setup, our patient, how it looks, our patient with a new setup. And of course, I will show you also, in this case, we use the face hunter and the face scanner. So with face hunter and face scanner, everything is becoming much more, let's say, much more easy. The possibility to use the face scan related to the models, to put the anatomy in the right place, that's absolutely something interesting and helpful in our daily jobs. So the setup, if you are doing the setup with the modifier, the new software Modifier, you don't need to create a project and select every teeth. Here you see that just with an upper and a lower, that's enough for me. Why? Because during the design, let's say into the modifier software, we can choose anatomies, and directly into the software we are able to choose if we would like to have 6 anatomy or 10 anatomy. So it's absolutely easy. In this case, I show you is one upper and just the antagonist. But if you have, for example, the 2 working, let's say arch, so if you want to do a setup upper and lower, just select LT upper and LT lower, and that's enough. So just to have finally what? Just to have a scan inside into the software, and to be able to load it into the modifier software. So the second step, once I select just these two anatomies, the scan software is, and we open the scan software. The software is offer me the possibility to choose one articulator. And you see that in the library there are a lot of articulators. But finally, also, it's not necessary to choose the articulator right now. I can also rediscuss the articulator inside into the software. I can choose different articulator, different way to mount the models inside into the articulator. So using a Facebook, a regular Facebook, or using our system, the plane finder, which is follow the natural head position, for example. And in this case, we would see also the process, the workflow to mount the patient into the articulator. So forward to the software, and here we are in, let's say, into the plaster room. Let's say that we can load and match data together, etc. So as we say into the presentation of the webinar, here finally we have digital data. So I'm not able to scan a model, so I just need to import the models. And how I can do it, you have two possibilities finally. In the upper part here of the software, you can see that you find the button Scan Action. And in Scan Action, you have the possibility to click on Import. Once you click on Import, you have different possibility to load and to import data. So you have the possibility to import one project complete. So means that you have already one project and you want to load the project, maybe modify the project, or implement the project to with another different data, STL, etc. Or you can also load mesh. So mesh means that you are able to load single mesh. Okay, and in this case, the starting is, of course, load the mesh, because the doctor scan the patient mouth with the intraoral scanner and just send me this data. You have the possibility also to load a face mesh, so means one single face mesh, or the face scanner raw data. So once you have scanned the patient face with the face hunter, you get a folder which is the name face scanner raw data. These are raw data of face scanned of the patient that they have not, let's say that they have not a relation one to the other. So they are just the raw data. And we are able to work on this data to match together and to connect this data to the upper and lower arch of the patient. So that's the second. In the second step, we will load the face scan. So once again, here in this scan software, out of the Scan Action, you have another possibility to load intraoral scan data. Directly here on the left side, you can see that you have healthy upper and lower. That finally was our project. So I have, if I click on these 3 points, I have just the possibility to load and import mesh. So I'm able to import directly from here. And so I have, for example, the upper and the lower data. Of course, you see that we have no orientation of this data inside into the geometry of the articulator. They are, let's say, in the position that the doctor sent to me, but they have no relation. So we have to rediscuss the position inside into the geometry of the articulator. That's basically the first. About immediate loading. Here, for example, you see that if the patient have no teeth, of course, you load the gingiva and you can start from this point of view. But if sometimes, or a lot of time, the doctor decide to remove, let's say, the teeth during surgery and place the implant at the same time. So we are also able, once we import, for example, let's say prosthesis or the old teeth of the patient, we are able to cut from the STL data the teeth of the patient, just close it and make our new setup. That's the possibility. Here, for example, you see the patient, it was with an old restoration, upper and lower, full arch. And as I told you before, the doctor decided to replace all the implants. You can see also from the scans that one of the implants is already outside. There was no connection with the bone finally. So once I have my models, let's say, into the software, I can decide to import, like in this case, that there was the face scanners of the patient. I can import the face scanner raw data. So I just looking for my folder, which is the name face scan raw. I select the folder, and really easy, I have my face scanner into this software. So right now, what I have to do is basically I have to replace and rematch all the data together and connect the face scan and the upper jaw and the lower jaw of the patient. Of course, the gingiva, different scans. I will show you how we can connect this STL of the patient and the face scan. And we will see right now the workflow. So I have a frontal face scan. That's my way, let's say, of working with this data. The data that for me are really important. So basically, it's one face scan complete. So frontal in rest position of the patient, frontal and lateral left and right. So in this way, we can align the frontal and the lateral just to have more three-dimensional face scan of the patient. So left and right, and we match together with the frontal. So with 2 points, and you can also paint an area and match together. The left, the same. So with 2 points and paint an area and match it. So here on the right side, you can see that we have already one three-dimensional patient with 3 scan. If you want to have more than this area here around the hair, you have also the possibility to make 2 more. So you can match together 5 scans to have one complete, let's say, reference scan. This I call reference scan. This that we see into the right is my reference scan. Okay, so once I match all the data in this way, I can save it. You can save it like as a complete one. It's not just a frontal, it's a complete. It's a mouth close, of course. Now we match with this face scale that basically is just an orientation into the software and nothing more than this, okay? So we just give an orientation. Then we have different scans inside into the face scanner raw data. So we have scans of the plane finder, which is our, let's say, face bone, which just follow the natural hair position. And we have different, and we can save directly as a plane finder scan. So just click on save. Once again, we align our reference here on the right side with the following scans, like the plane finder or different phonetics that we suppose help us during the design and during our workflow. So 2 points on the left, 2 points on the right, and match together. This here that you see here on the right side, this fork, which is the green fork, is the fork, the cover, let's say, of the original fork of the face center, which it was with markers, is a cover that allow you to match the face scan of the patient with the upper jaw of the patient in STL file. And that's an important step, because the position of the upper jaw, it is really important to have a connection, a correct connection between the patient face and the upper jaw of the patient. Let's say that our face center is really precise and you are able to match really accurate. There are into the market different face scanner. Also, you can scan also in 3D by the phone. But the problem is still here in the matching between the data of the upper and lower jaw and the patient face. and also that the scans with the face hunter is really stable. So if you take a patient and you scan 5 times in the same position and you have a look at the dimension is really stable and it's quite similar and the same, let's say. If you take a look with the face scan that you did with a different system or by the phone, you have not this reproducible dimension, let's say. So this is really important. So once we save this byte as a fork or whatever, you can match once again with the reference scan here on the right side, and after that, different scans starting from different phonetics like F and S and M. That's or A or E. Let's say that's something that helped me during the design. But there is also something more, which if you have a new software like the modifier, you don't need a lot of scans because the software modifier is able to combine data together, so face scan together. So if you have 3 scans starting from mouth open to mouth closed and crossing to a smile, let's say, the software is able to connect all these face scans. So with a simple slide, you can make the face scan with animation. So it's not anymore, let's say, a static face scan, but is animated face scan. So that's the great advantage also of one of the great advantage of the modifier software. So we save it as a rest position, for example, in this case. Different smile, the same. So 2 points, left and right, and match together. So different smile, as I say, that in my workflow there are normally 3-4 smile, starting from a normal smile to a heavy smile. There are different phonetics. Of course, there are plane finder. Plane finder is our Facebook and the fork. So once you save all this data, now we have all the face scan related one to the other. So we have one position for every face scan. So we have connection, let's say, and position one to the other. You can see also here that we use to draw some point into the patient face just to see and to be able to create some plane, some reference plane that help us during the design. We have, as I told you, we have here a group of face scans which is related one to the other, but we have the upper and lower jaw of the patient in STL file, which are not related to the face scan, of course, because that's something else. Okay, now we need to match everything together. How we can match together this data? So we are able, let's say, to import the intraoral scan of the fork. So the doctor scan by the intraoral scanner the fork. You can also do, of course, inside into the scanner of the lab, but basically that's something that coming from the dentist. So import, and in import we just load the STL file of the fork. Once we have the fork here, that's our connection. Our key connection between the group of the face scans and the upper jaw. Of course, the upper jaw is already related to the lower jaw. So I need first to match and to combine the fork and the upper jaw of the patient. Okay, so the orange will be the reference scan, and it's not moving, it's stable, it's there. I don't want to move it because we have the relation with the lower, so I have to keep it in that position, and I move the fork to the upper jaw. So here we can match because we have all the, let's say, occlusal surface, and we can match accurate. You see here from this texture that we have really accurate matching between the two parts. So in this step, we have the group of the upper jaw and lower jaw related to the fork. Now we need to match this group, upper, lower, and fork, with the face scan with the fork. Okay, so now we have once again the matching between the fork, and we use this geometry, this let's say balls that you see on the surface, that we are using this geometry to check and to be accurate into the matching. So you can see from the texture right now that we align the two data, that you have a texture between green and gray, and you can see that there is really accurate relation. So the other scans that you see here on the left, they are coming directly in position because there was already related with the fork. Okay, so in this moment, we have all the face scan related. So the fork was able to help us to match the data together. And we have the digital patient, basically. But it's still not mounted correctly into the articulator. We don't choose any articulator. We don't mount the patient into the articulator till now. So we need to choose our system and mount into the articulator. And in the meantime, also, we can also choose some reference plane that we can save it and use it as a reference during the design, during the setup. So here, for example, you can find also in Scan Action, you can find also the possibility to load the reference object and load different planes like the midline here, and you can draw directly and align the midline to the point that you draw into the patient face, for example. And then you have the possibility also to, as I told you, you have different planes. You have plane, you have regular plane, let's say, that you can use as a midline, as an interpupillar line, or as a ala tragus of the patient. Or you can also use some another plane like the golden proportion, and we will see later. Now, if we choose, for example, the Zirkonzahn system and the plane finder as a possibility to be able to mount the patient into the articulator correctly, you have directly here on the left side, you can see with plane finder. So we can choose by clicking plane finder a workflow that guide us from no position of the model to our relation correctly inside into the articulator. So the first step is, as the software is show you, mark the middle palate seam. Why? Because the skeleton midline is our reference to have correctly the patient into the articulator. So the skeleton midline is one of the basic parameter to mount correctly the patient into the articulator. And how? I can click directly here on the sutura palatina mediana of the patient with 2 points, and I can click also on the molar. Why the molar? Because the molar is our masticatory center, and the masticatory center is one of the other really important point for us to mount the patient into the articulator, because there is a distance, a relationship between the masticatory center and the rotational X of the articulator. There is a distance, which is a medium distance all over the wall, which is around, let's say, 90 millimeters. Okay, and so, but just to let you know, this is basically just a talk between us. It's not a deep course, and if you would like to be here or to have an online training, that can be, and you can go a little bit deeper in these data. Okay, but this basically just to know more or less how is the possibility to mount the patient using the natural head position. So we have basically these 4 points. And then the software is offer me the possibility to mark and to use the ala tragus left and right. Okay, so I have the possibility to click directly on the point that I mark on the patient face to use the the ala tragus. Why the ala tragus? The ala tragus is my reference to have, let's say, the inclination of the occlusal plane related, because let's say that there are a lot of studies that tell us that the ala is left and right, of course, because everyone is not symmetric. There are different studies that tell us that the ala is the reference to have the relation of the occlusal plane parallel to the ala. Okay, so ala left, ala right, and then when I'm here, the software is recognized inside into the folder, inside into the project. There are different phase scans with the plane finder. So, and tell me about numbers. What numbers are, let's say, all the angles that the software detect about this scan. So if I have 3, 4, 5 scans, it tells me all the angles, so that you see the roll and the pitch and the marker numbers here inside into the software. And I can compare also, and you can see that there is not so much difference between one. So you have 2.7, 2.8, and 2.8. So it means that between here one and the other, one is exactly the same and the other is 0.1. So it means that it's nearly nothing. And the patient, when I was scanned the patient here by the face hunter, was free, was not constricted in one position, was free. It was just say, okay, you have to stay in a certain position and I will scan you, and nothing else than this one. So it means that the system is really accurate and reproducible. So, and the important thing is that the advantage when you are using this system, when I'm here, I can select all these parameters and mount my patient using all these parameters. And the software is making medium of all these parameters to have the patient into the articulator. So that's the advantage, let's say, of a normal Facebook, that you have one possibility. And if you make a mistake with this possibility, you bring the mistake into the articulator. That's the great advantage of the digital, basically. Once we mount our patient inside into the articulator with this workflow, we can, as I told you, we can use different plane as a reference. We can give colors. We can use calota, different curve to different curve and different planes and different reference plane to use into the design and to the setup. Here you can see that, for example, we load one of the plane that help us to have the anatomy correctly into the setup. So you have this plate, which is basically a golden proportion plate, and you can set different inclination, left and right. You can have different size, so you have different size of this arch. And once you load this plate, the advantage or the relation between the softwares, so means that if you load and you save this plate here into the scan software, once you switch to the Modifier software, the anatomy will be stick immediately and really easy to this position. So it's help us to save time, really. I can show you later when we are into the Modifier. So that's a great advantage. Let's say we can set up inclination left and right just to have an idea about our occlusal plane. And it's a three-dimensional plane. You can see also from the frontal view, you have the size of and the position of the teeth. So we can see that here there are something maybe to correct. We can see the point of the canine on the left side of the patient and the premolar. Maybe we can have a look at that point and make a different inclination or a different position of the teeth. Okay. So once again, the plane are really helpful, and we save our project complete, and then we can start with our setup. Okay. Once I complete my project, I can start directly the modifier. So I have not, let's say, I can switch also. I can't. I can go into the archive and then start another software. I can open directly and say I can create a project. And here, once I'm into the modifier, I can choose different possibilities. So you have setup, you have orthodontic, you have the libraries, different library, you have the model maker, you have the prosthesis, you have the mockup. Let's say that this is a really accurate software and new software to create all the missing part that there was into the CAD, normal CAD software. So first we implement with the intelligent library first, and intelligent articulator. I will show you the possibility of the articulator during this setup. And the mockup, for example, the mockup is really easy to do it with the modifier compared to other software, and is the prosthesis upper and lower, or the partial denture. That's basically the starting point of the software. Here we can just load from the folder coming from the saving of the scanner, upper and lower, and we have already inside here upper and lower. Inside here we can decide directly if we would like to do an upper, lower. We can decide antagonist. We can decide working scan. So it's the advantage, let's say, of this software is that it's really flexible. So during the workflow, you can decide how many anatomy. You can decide if you want to have the upper working, the lower working, etc. And that's a really advantage. And I load these two scans, but immediately I have at the same time all the face scan of the patient inside into the software. And you can see also the plane that the golden proportion plane that we save before into the scan software is there, is in position, is in the position that we choose into the scan software. And now here on the left, we are able to load the anatomy. So I click on the anatomy library, and I have the possibility to choose, of course, different shape of anatomies, with root, without root, etc. But I have the possibility immediately to decide how many anatomy I want to have in my case. Let's say if I would like to have just 6 units, I just load 6 units. If I would like to have a full arch, I select a full arch. If I would like to have upper and lower, I select upper and lower. Okay, so I load the anatomy, and you can see the anatomy is not stick into the plate. But if I click on use plate here on the left, the anatomy will be stick immediately in the position that we choose into the scan software. And right now you see that it's exactly in position, and we can see that it's already there. The setup is already there. It's really easy. I don't want to explain or stay. We have no time. So for me, it was really nice to stay here and speak about all the features we have inside here, new possibility about the free forming or the placement is really interesting. But I will do it maybe next time. Let's say we have different possibility. The anatomy are really intelligent. Everything is connected. Also upper and lower. We can decide, for example, how to cut up upper and lower, different percentage, upper and lower, etc. That's help us a lot as a technician, to say. So we can adjust the anatomies. We can also load gingiva if you need the gingiva. As you see here from this view, you have the plate. The golden proportion plate. The anatomy is stick on the plate. And you can also add the gingiva in the second step. You can freeform, you can modify. But this is one of the features that I like really a lot of the software. And that makes the software for me really valuable. And that's the great possibility that give you this software. So you have the possibility to implement the articulator with the individual movement of the patient. Here was detected the individual movement of the patient with an osteograph, with a plain analyzer osteograph, and then you have the possibility to import this movement. So you have the button import real movement, so you have 100% of the movement directly inside into the articulator. And you can see that you have the different protrusion, lateral protrusion, left, right, and retrusion, etc. And you have the possibility, once you start the articulator, to create a surface of the movement. So the software is able to create, let's say, a fake model in STL file, which is the surface of the movement of the patient. And you can use it as an antagonist. So it means that you are able to cut and to control the movement between upper and lower really accurate. And that's really amazing. That's the advantage of the digital compared to the analogic world, let's say, because once you scan one patient with the analogic with the osteograph, and then you get a PDF with all the movement. You can of course implement all these angles and details inside into the articulator, but it's not 100%. It's still a medium of movement because you are not able to set all the line of the movement. And here I can move the model with 100% of the movement of the patient. So once, but we will maybe make a webinar about articulator. That's one of the possibilities, or we make a course. And here I can build up my workshop, and I have my workshop. So once I have my setup, it is a setup complete, a workshop, but without the holes, of course, of the implant, because this was not planned till now. So I'm able to send directly into the nesting software and to mill it, but mill it without the holes. And why? Because I can make with one of the possibility of the immediate loading is that use the double milling function. The double milling function we have inside into the nesting allow you to split the milling in two pieces. So you can mill first all the anatomy, and all the anatomy, let's say, from the upper part without any holes, and all outside, and so let's say make the big milling part first, and then once the doctor is making the surgery, he can really scan the position of the implant with the intraoral scanner. He send you the file. You will implement and adapt this exactly the same, this workshop, up to the position of the implant, and then you are able to add directly into the nesting the second part and mill the hole and the adjusting to the gingiva part. So first here I calculate just selecting the double milling function, the upper part and outside, and you can see also that we are using the 6T bar, the 2L and the 1L. So we are milling really fast this part because the 6 millimeter is able to remove a lot. And then in the second step will be the next part. So you can see also from this slide that in the lower part there is nothing milled, okay? And now it starts for me independent of the way that I choose to make the immediate loading. If it's the double milling, for sure I mill the first part, and then I will plan here in the implant planner the position of the implant, control the relation between the setup and the position, the new position of the implant, and send everything send the guide to the dentist, the surgery guide to the dentist makes surgery and send me back the file for the adaptation and mill the hole. And in this way, I'm able to glue the bases directly in the lab. If I make in a conventional way, for different reasons, because the dentist is far away from me, we have not the possibility to send out really easy and really fast our restoration. Let's say you can do here, implement here into the implant planner the setup, create your surgery guide, export from here the position, the new position of the implant, and adapt directly the position of the implant to the setup, and create the immediate loading, probably really passive immediate loading that the doctor is able to glue into the patient mouth in the surgery day. Okay, so here you can see that we import of this patient. Basically, the doctor sent to me 4 different combined data. So you have the upper, the lower, and you have what? You have the radiographic guide, which is this one, from where I can detect and save the STL file of the old prosthesis. And why? Because the old prosthesis or a new setup prosthesis radiographic guide can give me, first of all, can give me the vertical dimension correct of the patient and allow me to have upper bone, lower bone related with the vertical dimension connect. So for this step, we can use a different way to relate. We can use spots, radiographic spots that we can mill and implement into the prosthesis that we mill, or we can use also the teeth completely. We have a material which is completely radiopack. We can glue into the prosthesis so you can see. So here you see that in the upper part of the software, we have generate STL from DICOM. Okay, so we can use this possibility to save our STL file of the upper prosthesis. Okay, I have different possibility here to choose the resolution, to choose the quality of the surface, etc. And I save it as an STL file. And once here I save it, I need to do what? To import that file inside into the scan software. Why? Because I want to have exactly the same position of the setup. Everything has to be exactly in the same position. So every file will be immediately imported into the scan software and saved. So now I have the old prosthesis and the setup exactly in the same position. Now we're back, once we match together, we're back into our implant planner software, and we can import. We can import scan, okay? Import scan for what? Because I need to import my new setup, first of all, just to be sure about the position of the implant. So I import first the prosthesis that we save from here, which have exactly the same position inside into this folder of the setup, of the face scan, etc. And using this radiopack export, I can match it really easy, like that. After that, I can import the setup, of course, as a setup works up, and I'm really easy able to use exactly that position that have in the scan software. So here I don't need to rematch it. I use the last position, and then I can have it everything in one position. Also here in this implant planner software. So you have here the face scan. You have the new setup, and you have also the old prosthesis, the radiographic guide. Radiographic guide, let's say, is a copy of the old prosthesis of the patient with a different vertical dimension. That's all. Now we are going forward with the planning, and here you can adjust the brightening of the contrast of the light of the combine, and you can choose if it's an upper or lower. You have different possibility to select and to have a look at that, and you have the possibility to click on and detect the panoramic curve of the combine. Then the next step. In this step, we have the possibility to choose and to add implants. So just on the left side here, you have add and modify implants. So if you add an implant, you can see that the library is a really really important library. You can find out, let's say, all the most important implants that we have into the market, a lot of implants. And the advantage of this is that you can find the implant company, the implant type, the diameter, of course, and the length of the implant, and everything is connected. So you can have a connection also and choose the abutment size and the scan abutment too. You can choose MUA, for example. Like in this case, we was pretty sure that we plan to use the MUA connection, but you can see also from here that we can use the scan body. We can load the scan body, and everything have a connection. So once we load here in the software the scan body, we are able to export from the implant planner to the CAD software the scan body, and that's done. Let's say we can adjust the setup to the position using the scan body, and we can have the holes inside into the setup. I will show you later how to export and how we can combine this data together. So once we select the implants, here the doctor, as I told you, decide to remove all the old implants and replace implant in a better position. So we place the implant, and you can also here in this step select and load different pins. The pins that help you to fix the guide in a correct position. The guide, but not just the guide, let's say that you can use this position of the pin and match the pin also to the prototype, just to be easy. I will show you later that we can use these pins also directly on the surface of the prototype, just to be able to find the position and the vertical dimension really easy. And of course, here you can control everything. You have different possibility to have a look at the software. You have here, for example, this configuration is on the right side. You have the 2D view, and you have the 2D view also on the bottom here, and the 3D in the center. You can also change it. You can adjust. You can change everything. Here, once we load the implant, we have a look at the setup, and you can see for sure I was lucky in the previous Modifier step when I was loading the anatomies, because the position is, let's say, it's fine. I have not to adjust anything about the setup. You can see that the holes are coming out in a good position, let's say occlusally or palatinal in the frontal view. So we have not problem, and yeah, we can continue in this way. We have not to modify the setup. If you need to modify the setup because you have no bone or that's not a problem. You can just switch to the other software, just modify a little bit, re-import the setup, and control it. In this case, it was everything okay, let's say, in this way. But this is really nice when you have the possibility to analyze first a setup related to a face scan, and then you have the possibility to analyze the placement of the implant. That's amazing for me. And if you are working really close to the doctor, you can discuss, can we do it in that way? Can we do it in another way? So that's really important, and is make us, let's say, the team, the clinical team, much more close one to the other. And they can understand also the doctor, for the doctor, they can understand that they save time, they save time, they make much more accurate his own first prototype, but starting from the prototype, then is coming also the final restoration, let's say, and they can also save money, because if you have the holes coming out from outside, because they don't check about the possibility to make it related to the setup, then they have to they have to, or they or we have to choose abutment, inclinated abutment, or a bar or something. So everything is coming much more difficult, let's say. Once again, here we control the position of the implant related to the setup was correct. And then the next step is the possibility to load and to use different kind of sleeves. So the sleeves, let's say, is in the implant planning, the sleeve is the most, let's say, important step, because if you are creating a guide and you choose a wrong sleeve or wrong distance, then we have not any more connection, let's say, between the placement of the implant and the plan that we do before. So that's here inside into the software, you have different sleeves related to different surgery guide kit. So if you open the library, you can find a lot of surgery guide kit. If you don't find certain surgery guide kit, you are still able to create your sleeve as you want. So we are able to go in setting and create our sleeve as we would like to have. So that's not a big problem. Okay. So once we choose the sleeve, we are going to the next step. Next step will be, let's say, a starting point for different possibilities. So the software is a little bit stopped and is give you different possibilities. We can directly go straight for creating the surgery guide. So we can create the surgery guide with this position. That's one of the possibility, of course. We can also send all the project to another dentist or to the technician, or just to control it. If I'm the technician that I'm doing this step, that's not my part, of course. This is a part that the dentist have to do, but you can still send to this project to the dentist, and the dentist can modify the position of the implant and can check it, etc. You are also able here to create a PDF or to export all the data that we have here, like the scan body position, etc., the setup, etc., export for the CAD for creating the direct immediate loading. Okay. If I choose, for example, creating implant report as a PDF, I can send to my dentist. That's something important that the dentist could use in the surgery day. It could use this report to have a look at every step. So here you can find every information about the planning. So you have the patient name, you have the type of the surgery, different view of the implant position, let's say, and you have in details for every implant the specifics. So you can see that you have a noble or whatever, or trauma or whatever, and you have no collision. That's important to check it, that you have no problem, let's say, about every implant. And then you have the specific detail for every implant. You have a look also at the radiographic part of every implant. You can have a look. And you have also, this is really important, the possibility to have a look at the bone density of every implant. So you can see that here, starting from red to the green, you can see where you are into this setting. So we can have a look also during the placement of the implant about the bone density. But here it's important for the dentist. The dentist can see during surgery. Okay, this up to every implant. Once again, we come back inside into the software. Once we can save this as a PDF, and we can send to the dentist with the surgery guide and with the immediate loading. We come back into the software, and here we are able to create our surgery guide. So the first step for creating the guide is the block out of the undercut. So from the top, I can choose an insert direction, and I can block out every undercut of the model. Then I can draw the line of the surgery guide perimeter, and including also, of course, the pins. You can close it, and here we are in the step that we can freeform, we can modify, we can stamp inside holes and checking point, etc. And now in the next step, I will save it and stamp the hole inside into the guide of the pin and of the sleeves. In this step, the surgery guide is ready, and I can export and mail or print. So you have the two possibilities to export as a STL file or OBJ file and send to the next thing and mail it. We can also, as you see here, we can also save the folder of the data of the patient that we plan here. So I can save the position of the implant with the scan body position to create my immediate loading. I save this folder. Then, of course, I come back inside into my archive and I modify my project, and I tell to the software that now I have scan body. This step, let's say, is exactly the same if you do an immediate loading directly, like in one shot. You can export from the implant plane, like I show you right now, or if you receive the scanning, the intraoral scanning from the dentist in the surgery day, you can make the same. So we start from here, okay, from this step. So I change my project, I select here that I have a wax up, and I tell to the software that I have a scan body, okay? So I implement inside into the scan software the scan body position coming from the implant planer or coming from an intraoral scanner, doesn't matter. But I have to relate this one to the upper part of the patient and to the lower part. How to match it? Let's say that there are different ways to do it. Somebody asked me a lot of time how we can combine this. The best possibility to match this is to have some screw into the first data and some screw into the second step of the scanning, and the screw into the bone can help you to match together the data accurate. Here into the upper normally is not a problem. The problem is mostly into the lower. Let's say the screw into the lower for me are really fixed. And here, once we are starting our let's say adaptation of the setup inside into the modelier software, we can choose the implant related to the implant that choose the doctor into the surgery, and we can match the digital scan body to the scanned scan body coming from the implant planer or coming from the intraoral scanner. And this step is really, really important. It's every time one of the most important steps for the technician, because you have to check accurate the position by the color also. Of course, if you check this and you don't check it and you have a mistake, everything will be a problem into the fitting of the restoration. So that's a really important step. The second step here is the emergency profile of the case. Let's say for an immediate loading, emergency profile probably is not so important. For sure, if you do it in one shot coming from the implant planer, this is make no sense to stay here and lose time to do emergency profile. If it's something that coming from an intraoral scan during surgery, that could be, let's say, because we have the real scan of the gingiva in the day of surgery. So right now, the possibility to freeform, to adapt, if you need to do it, but already everything is done by the modifier before, so I don't need to modify anything here, and I'm go straight, and I just adapt the holes of the implants, and adapt to the gingiva, of course, and then I have my immediate loading ready. Okay, now I can send this to the nesting, and the nesting, once I load my blank with the first part already milled, it recognizes automatically the position. If I choose, of course, step 2, you can see here from the right side, step 2 of the double milling. Okay, the position is there, and the software is recognized automatically, and it creates the second calculation, the second CNC. So the second CNC will be what? Will be the adaptation up to the gingiva, the bottom of the restoration of the channel screw of the implants, and the adaptation of the implants. And you can see also from here that there is this just the second part calculated. Good. So basically, I will show you maybe before show you some picture of the surgery guide, etc. I will show you a video about the surgery, and you can see the surgery in the surgery day, what is happened with the doctor. Here you see the doctor is controlling the implants, and he removed first the implants, the old implants, and you can see that once the implant was really coming out really easy. That was the problem. It was not integrated accurate, this implant, and that's the reason, one of the reasons why he decided to remove it and replace it in a most, let's say, in a better position. And as I told you before, you see that you have no connection. The implant is coming out really, really, really easy. You have basically no connection with the bone. It's really clear, the implant. So that's the problem. You see the surgery guide here, the Miller surgery guide, and you can also use this kind of bite. Let's say that once you have everything into the articulator, you can relate it, the upper and lower with the stop with the resin, and you have the possibility to put it into the patient mouth, upper and lower, let's say really easy, and have a relation between upper and lower. This is the drilling of the pin holes, lower and upper. As I don't know if I mentioned to you, but this case was not a fully guided case, was just a partially guided. And here you see the doctor drill just the pilot holes into the bone, and then he removed the guide and he opened the flap. Why? Because I tell to the doctor the gingiva, the ridge of the bone is really, really thin and is really, really sharp. So if we are able to remove and to make more flat, is much more also healthy for the patient, because with the final restoration, it's much more easy to clean this area. So the doctor opened the flap and grind the bone just to remove this ridge from. You see that here, you take it and you remove it a little bit, the ridge. You make it much more softer and much more clean, all the bone. Now you drill the second step, the hole for the implants. Free hands, of course, the second step, but still with the pilot first hole that guide him to put the implants in a correct position. Of course, here was not using the double milling function, was just use the normal way, and the doctor glue the provisional, let's say, basis into the immediate loading directly in the day of the surgery. Here, the implant was a new implant used for this case, and of course, with in a second moment with the MUA abutment on top. And here you can see that the doctor fit the prototype. Okay, so now I will come back into here, and I show you some picture here, the milling surgery guide, and you can see that for example here into the prototypes you can also fit and glue with the position of the pin, like here, so you can fit directly the prototype exactly in position in the occlusion correctly. If you need also, there are some doctors, some dentists that would like to have, for example, a reinforced with a bar in cobalt chrome or something. You can also, as you see here on the lower jaw, you can also use that kind of possibility. Here, the prototypes, the immediate loading, upper and lower related with the pins, the surgery guides, upper or lower once again, and you see that once you have the pins correctly in the prototype, you can relate everything really easy. And here you see that after surgery, that's the result of the immediate loading on patient, and let's say was a good result of the immediate loading. Of course, there are some adjustments. The case is not finished yet. We are in the prototype step, and soon will be zirconia for sure, and upper and lower. I'm pretty sure I would like to use a bar in titanium into the lower, maybe a screwed bar, a double screw bar, and an overstructure in zirconia. And that's the result of the immediate loading. And let's say that that's all.